Right, now that we know the products that are created from weathering, we can start talking about soils. So soils, they contain all of that stuff that is produced from weathering, right? They contain the broken down minerals, they contain a lot of water and air and organic matter. And all of these broken down minerals contain elements that are really, really important for our ecology, our environment, right? So soils support ecosystems and are really, really important resources. Right, so what are soils made up of? Right? Well, we talked about how quartz is one of the hardest things to break down, right? So it's going to stay in that larger grain size, which we're going to call sand, that really coarse, gritty grain size. And other minerals that aren't quartz are more likely to break down into smaller and smaller and smaller and smaller pieces. And the tiniest grain size we call clay. Right? So phyllosilicates are those clay minerals, and they're really, really important to soils. And as I said, soil formation is controlled by climate, right? So the hotter and the wetter the environment is, the more weathering you're going to get. So let's break down some of these environments and talk about what type of weathering is going to happen in each of them. So let's say it's really, really hot, but it's also really, really dry. So a hot, arid climate. Right, so there's not a lot of water, there's not a lot of precipitation, meaning there's not going to be a lot of carbonic acid, meaning there's not going to be a lot of chemical weathering. Right? Instead, there might be some mechanical weathering or physical weathering. So erosion that happens here is often minimal, but it does create two things that are important. The first one is calcrete. Calcrete is a hardened surface of soil due to the crust of sand, silt, and chemical precipitates. So if you've ever been anywhere that is really, really dry, maybe you go out into your backyard after a drought, right? You're going to feel that really hard crust on top of your yard, and that's calcrete. Desert pavement, this is the really rocky layer that remains after wind erodes smaller particles. So now maybe you go outside, it's after a big windstorm, a lot of the silt and the sand have been blown away, and all that's left are predominantly larger rocks, and we call that desert pavement. And both of these have a really low infiltration rate, right? So they're kind of like a cap on the surface of the earth, not letting water filter down into the subsurface, so further reducing the amount of chemical weathering. All right, now what about hot, humid climates, right? So we're going from the desert to the tropics. So humid climates mean there's a lot of precipitation where there's a lot of water, you're gonna get a lot of carbonic acids, you're gonna get a lot of chemical weathering, right? And you're also gonna have a lot of ions in solution. And we talked about how ions in solution, right, as they move through these soils, they're being taken away from the rocks. We call this leaching, right? So water breaks down the rocks, breaks down those minerals. Ions from those rocks, those charged particles in those rocks are leached away and taken away. And this can actually degrade the productiveness of the soil, right? Make it worse for planting and growing things. All right, we've talked about hot, dry, we've talked about hot, wet. Now let's talk about cold climates, right? So we're going up to the high mountains, we're going to the poles. All right, so here, there's a lot of water around, but it's solid, it's ice, it's not liquid water flowing. So again, we're not gonna have very much chemical weathering. Instead, we're gonna have more mechanical weathering. So think like freeze thaw is gonna be really common here. Right, and finally, we're gonna get to where we live, which is a temperate climate, right? Not too hot, not too cold, somewhere in the middle. And here is where we get soil formation that we're more familiar with. And here, soil horizons are developed, right? So if you took a shovel and you went into your backyard and you started digging a hole, you're likely to find layers of differently colored soil. Right? And each of these soils have different colors because they're made up of different things. So first we have that really, really dark, rich, dark brown layer on top, and that's that organic material making that dark color. Then we have the A horizon, which is the topsoil. Deeper than that, the B horizon. Deeper than that, the C horizon, right? But as you see, because of the soil formation, because of the weathering processes in temperate climates, we get these soil horizons that if you've ever dug in your backyard, you've probably seen before.